So here's the next problem. Again, if you want to hit pause and write it down, that's fine. Okay, so instead of baseball, we're going to football. It's football season here in the fall. So we're going to try and solve something about a quarterback throwing a ball to a receiver. Okay. As usual, these books like to add in feet and yards and different units. So I put over on the side there 30 yards equals 90 feet because that's going to be important for us. Okay. To start these type of problems, I think we would immediately want to set up our R of t's. Okay, so our R of t in this case is v naught cosine of, do we have an angle? Do we have an angle? Yes, 35t. And then we would have negative 16t squared plus v naught sine of 35t. Plus an initial height of 7 feet off the ground. Okay. Notice, I don't give you the V naught. I give you the angle. I don't give you the V naught. And that's our whole goal in this problem is, look at question A. Find the speed of the football when it is released. Find the V naught. That's what I'm wanting us to do right now, is find the V naught. Okay. Well, it gives us a couple pieces of information. It tells me that it is caught 30 yards directly downfield. That's your x. And it's also saying at a height of 4 feet. So because we have the x component and y component and we separated it out, we can actually extract that out and say not 30 yards, but 90 feet has to equal v naught cosine 35t. And we also know that at 4 feet, that has to be negative 16t squared plus v naught sine 35t plus 7. Okay. Now, within this, you need to realize you currently have 2 equations and 2 unknowns. And those unknowns being at what time did this happen and what was that initial velocity. Okay, because it happens at the same moment. At that time, it is at 90 feet and it is at 4 feet. Okay, from here, I really don't need to do more on this because this is an algebra question, but I will to just let us kind of see how this unfolds. But really, we already did the calc part. We got R of t, we extracted out the x and the y. Now the solving part's algebra. Okay, so if I wanted to solve this, either think elimination or substitution. Elimination is not going to work because it's so different, the 2 equations. It's not linear, so elimination is a little bit harder. Okay, but I could do substitution, and I'm going to use the green guy first, and I'm going to solve this guy for t. I'm going to get 90 over v naught cosine of 35, and there's my t. And if that's my t, can take that t and I can plug it in to the green, or sorry, into the blue. So we'll use that and we'll plug it in. Okay, so I got 4 equals negative 16t squared plus, well, let me not say t squared. Just plug it in this way. Negative 16 90 over v naught cosine of 35 squared. So negative 16t squared plus v naught sine 35 times my t, which is 90 over v naught cosine of 35 plus 7. Okay. If you stare at this, the only variable I do not have is the v naught. Okay, so simplifying just a little bit, I got 4 equals, lots of big numbers here. 90 squared times negative 16 is negative 129,600 all over v naught squared cosine squared of 35. I know it looks ugly, and I'll show you how we can solve this. So I squared all that out. The next guy is actually kind of nice. The v naughts cancel, and the sine over cosine just turns into a tangent. So I got 90 tangent 35 plus 7. Okay. So that simplifies it a little bit. Okay. Now let's see, what else could I do? I could maybe move the 4 over and say I have 0 equals this ugly thing plus 90 tangent 35 plus 3, because that 4 drops the 7 down to a 3, and I could solve. Okay, a couple ways to solve this. I only have a v naught. Can I get v naught by itself? Okay, could you solve for v naught by himself with algebra skills? Yes. Okay. Another way to solve it, and one I want to look at just for getting that calculator out and practicing, is I want to look at this guy with it on the calculator, so you can see not only the actual answer, but where you can also see what's happening with a variety of the v naughts. So, oh no, sorry, that's the next problem. Yeah, next problem. Can we solve this? I'm sorry, just rambled for a second. I moved that 3 over, but that was kind of silly because I want to get v naught by itself. So let's see if I can do some magic and say -3 minus 90 tangent of 35 equals -129,600 over v naught squared cosine squared 35. Okay. And then I could multiply over and divide over. So I could say v naught squared cosine squared 35 equals -129,600 over -3 minus 90 tangent 35. And could I then divide by the cosine squared 35 and take the square root? So v naught equals square root -129,600 over -3 minus 90 tangent 35. All that times cosine squared 35. Okay. Some of you actually might have moved it the other way around, and you wouldn't have had all those negatives. But those negatives are going to cancel each other out when you solve this. And you get 54.088 feet per second. So it was released at that velocity at that angle. Okay. So when you pull back up here to see if we've solved any of the questions, it says find the speed, find the max height, find the time the receiver reached the proper position after the quarterback released the football. Okay, well, a couple things. I didn't really find the speed yet, guys. The speed is, well, for today, we're going to say this is the speed. Wait, let me think for. So remember, the speed is actually the magnitude of RT. So you know the time, or we got the V naught, check. Could you plug back in to get the time? Check. So then could you go find the speed, go find the max height? Could you go find the time the receiver has done it? Once you get the V naught and that T, remember that T comes directly from this boxed in part here. You get the T. Once you have all those things, I think you can go back and solve all the problems of when the max height is and how long it took to get to that position and those sort of things. Okay. All right, last problem. Let's take a look. Initial speed not given again. A bale ejector consists of two variable speed belts at the end of a baler. Its purpose is to toss bales into a trailing wagon. In loading the back of a wagon, a bale must be thrown to a position of 8 feet above and 16 feet behind the ejector. And then there's your two questions. If you want to hit pause and write it out, that's fine. And then obviously I'm going to draw a picture. So I got, and this is going to be a sweet picture, I got a conveyor belt. okay? And a thing of hay. I'll spell hay so you know exactly what it is, okay? And I need to put it over on a truck. Here's my truck. And it needs to land right here on that truck. And let's see, it says 8 feet above and 16 feet behind, okay? So, and I'm going to try and shoot this hay my ultimate goal is to land it there, okay? Now, a couple things to think through on this. When it says find the minimum initial speed and the corresponding angle, I want to talk about the angle for a moment, okay? If I set this up, I'm going to draw this in, and I'm going to set that theta right there, okay? Could you find on that picture, the blue picture, could you find theta? Yeah, you could say tangent theta is 8 over 16. So that makes theta the inverse tangent. And let's do it in degrees because that's what you kind of are more comfortable with. Inverse tangent of 8 over 16. That's 26.56 degrees. Okay. Now, 26.56 degrees. Let me ask you this. The corresponding angle for the minimum initial speed, can it be 26.56 degrees? No. That could be it maybe if you had an infinity speed off the conveyor belt, because an infinity speed off the conveyor belt would make the hay shoot off in a straight line. If it was an infinity speed. When you're talking minimum speed, if you talk any projectile, okay, notice the curve on the yellow. Do you see how it bends a little bit? Okay. If I actually did do that bend with that angle of 26.56, this is what it would look like. And it's going to come up short because gravity is going to pull it down. So at least the thing you know is it's going to be more than 26.56 degrees. Okay. And then obviously it has to be less than 90 degrees, because if I did 90 degrees, it's going to shoot straight up. And if I did it more than 90 degrees, it's going to shoot it backwards. So at least you're starting to get a range or a window of what it could be between what and what. Okay? So that's just a good way to think through it. I know I'm greater than 26.56. I know I'm less than 90. Somewhere in there is going to be the angle. And who knows about that initial velocity component yet. Okay? So, as usual, we start R of t. Let's see, x component is going to be the v naught. And this is v naught cosine theta of t. We actually don't know the angle this time. And the y component is negative 16 t squared plus v naught sine theta t plus my initial height. Now, I don't tell you how high up the ejector is, but we can always set basically this right here as my origin. Okay? So if you set that to be our origin, then the goal is to get it up at 16,8. Okay? So let's just say that initial height is 0. Okay? All right. Well, let's see if there's anything that we do know. And I just wrote it on the truck. My goal is to get 16,8. So I can extract that out and say 16 equals v naught cosine theta t. And I can also extract out 8 equals negative 16t squared plus v naught sine theta t. Okay? So I have the 16 equals and the 8 equals. Okay? Now, let's see. How many unknowns do I have right now? Okay, let's look at this. Kind of interesting because it's a little bit different. 3 unknowns. V naught, theta, t, and how many equations? I have 2 equations showing right now, okay? I have that equation and I have that equation showing right now, okay? So a little bit different than the last problem where it was 2 unknowns and 2 equations, okay? So look what happens as you solve this, because it might seem like we don't have enough info, okay? But we have enough info once we graph it, okay? So let's see, solve for t, okay? I'm going to solve for t. And in my mind, the easiest guy to solve for t is that guy. So t equals 16 over v naught cosine of the angle. Okay, once you solve for the t, you can plug that t in. So let's plug it into y. And I would get 8 equals negative 16 over v naught cosine theta squared plus v naught sine theta 16 over v naught cosine theta. Okay, so I have that. Now, my goal is this. You can't solve this because there's 2 unknowns, the v naught and the cosine theta. But my goal is this. Let's solve into this form. I want it to turn into v naught equals stuff. The reason I want that is if I get v naught equals stuff, could I graph that on a calculator? Because it would be v naught in terms of your theta, and we can look at stuff from there. Okay? So let's see. Let's solve. First off, let me just simplify some things. So I'm going to say 8 equals 16 squared times the negative 16. I can get that to be negative 4096 v naught squared cosine squared theta. And the sine theta, cosine theta, they drop to a tangent, and the v naughts cancel. So I got that plus 16 tangent theta. Okay, so that's a start to this. So then I might move over and say 49.6 over v naught squared cosine squared theta equals 16 tangent theta minus 8. Okay. Then doing a little cross multiplying, v naught cosine squared can be 49.6 over 16 tangent theta minus 8. And finally, you can say v naught equals square root of 49.6 on top, 16 tangent theta minus 8 times cosine squared theta. And you could simplify a little bit. Maybe that 49.6 simplifies in the square root. The cosine squared obviously just pops out a cosine on the bottom. But for right now, this is perfect. I'm going to leave it like this. Okay? And I want us to graph this. And we're going to talk about what it looks like when we graph this. Okay? So spend a moment in your calculator setting this up by graphing it. I will as well. Okay, so I graphed it here. I'm going to be in degree mode. So I put it in degree mode. And then when I look at my window, I know 0 to 90 because we talked about it. And I could really do that, whatever it was, 22 degrees. But let's just get the whole picture of 0 to 90. I have no idea on what the max velocity is, so I'm going to make that 100. And let's just see what happens when I graph it. So when it graphs, it comes down, it hits at some point, and then it goes back up. Okay? Now, there's an important thing to know about this, and I'm going to hit trace, And I want to show you, what was that angle again? 26.56. That was the minimum. Let me highlight it here because I'm at my computer so you can see it a little bit better. That angle we said was the minimum angle. If I was going super, super, super fast, I could do that angle because it fit that blue triangle that we had set up right there. So let's look at that angle, 26.56 degrees down here. So I hit 26.56 degrees. Okay. Whoops, I hit it wrong. Okay, when I go all the way up, okay, I need to hit pause. All right, guys, it's been after 4 days, so I've screwed this up. Now, let's start all over again with, this is the correct equation that I did not type in originally. And it looks like that, which is similar. I just had it typed in wrong. Now, if you hit the 26.56, look at that. There's this blank there. What is that? If I hit just to the right and I come down, what is going on at 26.56? It's an asymptote because we can't do it, because we can't have infinity speed. And we can look all the way over here, and where does it look like another asymptote happens at? 90. Because if you have 90, it doesn't matter how fast you're going, it will not curve over to hit the hay bale on the truck. So there's two asymptotes, and my whole goal, as tons of Calc 1 students are surrounding me and annoying me, is I need to find that minimum, okay? So that's the whole goal, is I want to find that minimum. So let me calculate the minimum. Got angle left, angle to right, and okay, I'm going to try and snap a picture of this for us to see. Okay, and copy that. I'm going to close this up. Put it in so we can look at it. And let me extract out a couple things for us on this. So I found that minimum. And I just want to remind you that there was an asymptote right there at that angle we found originally, which was, what did we say it was? 26.56 degrees. And you should know that is right here. What did we find right there? That's zeroing the bottom, which creates a vertical asymptote, okay? And can we zero the bottom again over there? The whole issue is, at 90 degrees, it doesn't make sense either, because you could have it as fast as you possibly want, but at 90 degrees, it's going to shoot it straight up. So at 89.99 degrees, it could work.
There will be video announcements today.
So, thank you. Video announcements.
Happy Tuesday, Rocky Mountain High School.
Okay, so 90 degrees, you can't do it. That'd go straight up. But if it's 89.999, you could, as long as you had tons of speed, because that would look like shoot up, shoot up, shoot up, shoot up, shoot up, and it comes back down and hits. That's a big time speed. And then you can also do it with the bare minimum of that 26.56 if you had an infinite amount of speed. Okay? But for our point and purpose, the question said what was the minimum velocity and at what angle was that? So my minimum V0 was 58.28 feet per second, and it was at the angle of 28.78 degrees, which is, again, closer to that 26.56, obviously, over the 90 degrees. Okay. Part B we won't worry about. Okay. So there is some problems. Sorry about the scatteredness of my brain in the last 5 minutes. And there is your homework. Have a good weekend.